So hi, I'm Professor Cassie Gaston. I'm faculty in the Department of Atmospheric Sciences at the Rosenstiel School, and this is partially where I work. So this is Ragged Point in Barbados. It's the easternmost part in the Caribbean, and this is also a receptor for long-range African dust transport, believe it or not. The dust has a lot of impacts on ecosystems, on clouds, and also potentially on human health. And that's what we study in my lab. So I'm going to show you around our laboratory a little bit of what we do, just to give you a feel of what kind of science happens here. So come on with me. All right, so this is our site. So we're on a cliff right at Ragged Point, and then we have a few things going on here. So we have two containers. So these are actually shipping containers that we've modified into labs. And they house instrumentation, so ours as well as guests. So people come from all over the world to sample here because it's a great place to look at how natural as well as man-made aerosols, which are tiny particles in the atmosphere, affect the air we breathe as well as our climate system. So what we have, in addition to these sampling containers, is a tower. So this is about 54 feet high, right? And it's also sitting on top of a cliff. So we get pretty high up. And this is because the dust that comes from Africa actually comes pretty high up. So we have to catch it by going high up with our sampling. So that it can withstand this environment, which is hot, humid, and also really, really salty. There's a lot of sea salt in the air from all the wave breaking. And when we go up the tower, we actually have instrumentation up there. So we have weather stations to look at things like wind speed, how humid is it raining. We have also filters that we've been collecting since the 1960s. And this gives us a long-term time series of how has African dust concentrations changed in the Caribbean over time, and what does that mean for the climate as well as health. And then we also have a new instrument that we just put up a few days ago. You saw a video probably, or you will see a video on that going up the tower. And that's the first instrument in Barbados to basically provide air quality monitoring. So looking at particles, how many particles are in the air of a certain size, and what does that mean for health. So I'm going to take you up the tower and we can have a peek. All right, so why this site is so unique, like why has this been here for so long? What's the deal with the site? So the reason why the site is unique, for those of you who aren't familiar with Caribbean geography, so Barbados is the easternmost island in the Caribbean, and Ragged Point is actually the easternmost site on the island of Barbados. So we're as far east as we can get within the Caribbean. And so the nearest landmass to us when the wind is blowing from the east, which it does because we're in the trade winds, is Africa. So what that means is that when African dust is transported over the Atlantic Ocean, we're the first place that gets it, right? So that means we can really look at the properties of the dust before it gets altered by any man-made emissions. And this is really important because it gives us a long-term barometer of things like African climate. Are the African deserts drying, or are they becoming more moist? So we can see that by looking at how much dust makes it to the Caribbean, right? And then we can also look at things like, okay, well, how is the dust impacting things like not just clouds, but also things like hurricanes? This is the research hub for looking at answering those questions. All right, so this is inside of our lab. So what we have here is in the back wall. So these are where we monitor the pressure of the pumps that are on top of the tower. So this is where we record things like how much air is being sucked over that filter paper that we collect every day. So that's where we monitor that. We also have a couple of other instruments from other labs. The ones that are ours include this instrument set here. So what this is recording the meteorological data from on top of the tower. So things like wind speed, direction, how much rain, relative humidity. And then this is a particle sizer. And so what this is doing is it's looking at how many particles are in the air, going from about half a micron up to about 20 micrometer in diameter. right? And then what we do is we stitch that together with another sizer that looks at the smaller particles, and then we can see like how many particles there are of a certain size. That's important because small particles, when we inhale them, they go deeper into our respiratory system, and they're also more difficult to activate as cloud droplets. So particle size is a really important measurement that we make. We also look at chemistry. So this is a mass spectrometer. So it's the first that we've ever had out here, which is really exciting. So this is an aerosol chemical speciation monitor, and what it does is it pulls in air. So this is an inlet that's coming from outside. It actually goes all the way up the tower. It pulls in air. We dry the air because we're going from hot, humid to more air-conditioned and dry air, which can cause condensation, and we don't want that. And then the air gets pulled through this manifold. Sometimes the instrument sucks in filtered air, which gives you a background measurement, and then other times it measures a sample. It goes into this instrument here, which is a mass spectrometer. What happens is the aerosols get accelerated, they hit an oven that vaporizes the aerosols, so it heats them up until they go into the gas phase, and then we use an electron beam to create ions, and then we can look at what sorts of ions we created. And what we can see here is we can look at things like ammonium, we can look at sulfate, nitrate, chloride, and organics. These are very common components of aerosols. What you can see is that it's very clean right now, but we'll take a look at it again later when we get a more dusty period, and we'll prepare, and that'll be really fun. So this is that particle sizer that I mentioned that's looking at those bigger particles. So this is what it looks like. It looks like just a box right now, but when we take it apart, you can actually see the intricacies of it. And that's part of what we do here is when instruments don't work, we take them apart and we get to learn like, okay, this is what we have to fix, and we do a lot of that. And then this is a nephelometer, and it's measuring particle scatters. So we can look at things like how are particles interacting with sunlight? Are they reflecting it, which would have a cooling impact, or are they absorbing it, which would have more of a warming impact? So the sister instrument to this is another instrument called an ethylometer, which is down here. That's what's making that loud noise, is we pull flow for a dryer to keep the aerosol dry. But this is showing black carbon, which absorbs at all wavelengths. And then this is particulate matter that absorbs in the UV, which tends to be things like organics from biomass burning. So you can see these measurements are varying quite a bit, but it's still very, very low, which is typical for a marine environment when we're just measuring things like sea spray. And then this is a scanning mobility particle sizer. And what it's doing is it's measuring particles from 10 nanometer up to about 1 micron. So it dovetails with that APS, or aerodynamic particle sizer, that I just showed you. When you put them together, you basically can look at the full size distribution. When you put the ethylometer with the nephelometer, you can get scattering and absorption. And then when you look at our filters and compare it with the ACSM, you're basically getting size resolved chemical composition, which helps us answer some of the most pressing research questions that we have, not just at Ragged Point, but in the whole climate community. How are aerosol particles affecting clouds, direct incoming solar radiation, as well as human health? And these are the integral measurements that you need to answer those questions. All right, so new day, new look, right? So last time we saw, it was a clear day, right? We didn't have a lot of haze. The visibility was really good. You can see today we actually had some dust roll into Barbados, right? This is why this site is very famous, is because it is a receptor for African dust. And so all that haze that you see out over the islands, and you can see some of those features, those little points out there are hard to see. That's because there's high quantities of African dust that are in the air right now. And we can actually see that on all of our instruments. So right now what we're seeing is an increase in aerosol optical depth being measured by the NASA instrument on our tower. And then also we have increased concentrations from our mass spec, And we're also seeing like a shift towards larger particle sizes as well. So we basically went from the cleanest day that we've had all month to the dustiest, all within less than 24 hours, right? And these are the types of events that are pretty typical around here at Ragged Point. And this is what makes this such an exciting research site, not just for us as atmospheric chemists, but also for meteorologists and others who are interested in looking at these phenomena. So this is one of the issues we're actually really interested in, not just in Barbados, but across the Caribbean and also in South Florida, is why are we getting increased concentrations of sargassum? So sargassum is kind of like a harmful algal bloom. It smells quite pungent, it smells pretty bad, but also you can see it's piling up on the beaches here in Barbados, so this has impacts on tourism. And also, I mean, once this seaweed is on the shore, what do you do with it? Do you compost it? People have been concerned about there's high levels of heavy metals in the sargassum, so that might not be good for human health. The sargassum, some faculty at University of Miami are showing that it's actually a vector for pathogens like E. coli and staph. So it's a real issue that we just don't know how to deal with it. Do we put it in a landfill? Do we try to compost it? Do we try to use it as a fuel? This is an active question that a lot of the faculty, both at Rosenstiel and at the College of Engineering, are trying to tackle together through the Center for Aerosol Science